Hello everyone, and welcome to our latest PV TechTalk Product Series webinar. I am Mark Osborne, Senior News Editor at PV Tech and the moderator for this webinar, which is going to provide an overview of Seraphim Solar's recently introduced S2 all-black half-cut module series, which actually combines high performance with superior aesthetics through some innovative adoption of new materials, which is focused obviously on the residential markets around the world. Our guest speaker today will be Carl Lee. He is the Regional Sales Director for Seraphim Solar. So a quick reminder that we have time for a short Q&A session after Carl's presentation, and so feel free to post questions throughout this webinar. We also have Seraphim staff online to help answer any questions you may have in that side of the platform. So if you're ready, Carl, it's over to you to start your presentation. Thank you.
Thanks, Mark. I'm ready. And thanks to Mark's introduction. And it is also my great honor to do this webinar together with the PV Tech. And at the very beginning, I would like to take this chance to extend our best wishes to everyone. Stay safe and be healthy. This year, we really realized that to be clean and to be energetic is so important to keep our healthy. Today, our talk will be on the full black module from the Seraphim that can produce the clean energy, not only for today, but also for future. Meanwhile, it is pretty friendly to aesthetically minded customers. First of all, please allow me to make a brief introduction about us, about Seraphim Solar. We are an experienced module manufacturer with about 5 gigawatt capacity in total globally, and more than 8 gigawatt shipments already completed till now. We have been in the Tier 1 list ranked by the Bloomberg New Energy Finance in continual 5 years, and also has been recognized as the top performer in 3 times by the PV Evolution Lab. Thanks to my colleagues, about 100 technicians' effort on research and quality control, we have won more than 50 global financial partners' trust on Seraphim brand. The layout of globalization is another key strategy that Seraphim insists on. We have set up about 8 sales centers outside China, like in Spain, Italy, USA, Japan, and Australia. Besides the module plant in Japan, we also established a 300 megawatt module factory in South Africa, and the 500 megawatt cell plant in South Africa is under preparation. As I said at the very beginning, today we are going to talk about the full black module from Seraphim. So what will be the main target for this model? Definitely it will be the rooftop markets. First of all, let us see the market review on the rooftop systems. From the left chart, it clearly shows the very fast increasing of the global PV installation between the 2011 to 2019. The number is from 30 gigawatt to 115 gigawatt, nearly quadrupled. And among them, it is pretty stable that more than 1/3 of the newly built PV systems were from the rooftop area. As well known, solar industry it is easily impacted by the policy, but luckily, upon the rooftop markets, most countries published a very pretty positive policy to support it. For example, like the nearly zero energy building policy in Europe, from the right chart indicates the very stable increasing of the rooftop markets from the Europe area. Rest like Australia, as one of the most decentralized energy markets in the world. A Bloomberg Energy Finance report says that Australia currently has about 11 gigawatts of solar capacity installed behind the meter, but among them, dominated by the residential. The segment shows no any sign of slowing down in the Australian residential market. Currently, the penetration ratio it is about 28%, but it is forecasted that by the 2050, it can reach 56%, nearly doubled. like in 2018, California enacted the 100% Clean Energy Act, which sets up a goal to source all electricity from renewable and zero carbon resources by 2045. Solar energy actually not a strange industry to the whole world now. From my knowledge, the earliest solar panels that installed in China has been more than 37 years ago. It is in Gansu province. When the solar energy entered into the residential buildings market, more and more the customers, the homeowners, become very particularly concerned about the look of the solar installation, as their single-story gable roof house might be just on the street corner in a very prominent location. So to achieve a balance between beauty and function becomes very, very important topic. As we can see from the three pictures, in the historical rooftop projects, we have to admit there are several aspects that might be improved now, like the first one, style mismatch. The obtrusive color clashing installed on the residential roofs caused by the regular modules like in the silver frame and blue cells. Sometimes they might look like a patch. The color deviation is another challenge. In one single piece system, even within the same piece of the solar module, color deviation can be very obvious. Rooftop project safety is another aspect we have to pay great attention to. Currently, till now, the regulation on this part have become more and more strict. Like in USA, 2017 National Electric Code calls for the module level rapid shutdown instead of the previous array level shutdown requirement. The same regulation has been applied in Europe, Australia, and Japan. Even in China, we all start to do the same regulation in some areas. Although this kind of function might be achieved by the inverters or optimizers of individual devices, but solar module itself also has to improve the reliability. So when it comes to addressing the aesthetic concerns of residential customers, the blank-on-blank module definitely should be the best solution. Its monolithic all-black look, especially with low-profile flush mounting, gives a very architecturally pleasing look, akin to the skylights. However, there are still some concerns on the full black module, like the one from the left. When we talk about the blank module, the cell that we used is a real black module or just the dark blue cell. From my previous experience from the ready garment business, blank is the hardest color to be dyed. Even with the right painting number, it is not feasible to achieve 100% print cells only with one color. The color gap is avoided. And safety is another common misgiving that customer may have on the blank module. Compared with the white backsheet, black backsheet is of some disadvantages on the heat radiation, especially on the hot temperature. This has become a main concern on some customers' final decision. So, when there is a problem, there should always be a solution. Let us see what Seraphim can do. This is Seraphim's full blank module. The sober design clamped to roof without any trace of white line is our target when we want to present our customers. So why we could make it? In Seraphim full black module, as you can see from the left part, the regular black backsheet, black frame, even the black adhesive are applied. If you see the right part, we also introduced the real black cell, half-cut cell module together with the full blank, and also we introduced the blank bus bar. Seraphim full black module appear more matte and have a more uniform black color due to a dedicated cell blankening treatment. So normally when you take to the mono cells, there will be a color gap among the cells from blue to black, as you can't 100% print the cells with only one color in the manufacturing process. Normally, black color cell consists only about 10 to 20% of your overall output. So in order to solve this problem, Seraphim inline blank cell production lines adjust the silicon nitride film specifications by adding the nitrous oxide to secure the color uniformity. To achieve this result, additional equipment will be required. The reason that Seraphim to do it is because we also faced a challenge on the color deviation in previous cases. So we want to take this chance, take this knowledge to delete the problem from any case. And also from the right chart, right part, you can see, we also used the blank coated bus bar design to ensure the full blank appearance. We conducted a very strict test on the to ensure the viability for 25 years. So what we want to in product design is the right balance between the aesthetic and the performance. The highest all-blank module output that we are offering now is up to 365 watts, and the module efficiency can reach 19.67%. We have talked about a lot in previous pages about the extremely aesthetic appearance of our model. Now let us see its performance benefit to be the half-cut cell design. As we all know, when solar cells are halved, their current is also halved. So resistive losses are lowered and the cells can produce more power. Smaller cells experience reduced mechanical stresses, so there is a decreased opportunity for the cracking. Half-cell models have higher output ratings and are much more reliable than traditional panels. On the other hand, half-color cells are more resistant to the effects of shade too. So our half-cell module series effectively turn each panel into the twin panels. Since the cells are smaller, inter-cell spacing doesn't have to be as wide, and they can be placed closer and together. Independent upper and lower module halves lead to improved shading response. So it means if the bottom half of the module is shaded, the top half will still perform. Due to the improved module output and efficiency, the BOS cost and installation cost can be reduced accordingly. To combine with the half-cut cell design really help us to improve our full blank module's performance and reliability. Let us see the two study cases when different shading happened. So what will be the difference between the traditional full cell design and the half-cut cell version? From the up two pictures, so when the 1/4 full cell shaded after 1 hour in our simulation, as we can see, the hot spot temperature on half-cut module is about 48.4 degrees Celsius, while in the full cell design model, it is nearly 40 degrees higher. The power loss on the half-cut cell model, it is about 18.4%, while on full cell model, this number nearly doubled. In the bottom part, so when the whole solar stream shaded, the result is nearly the same as the up part. So to check the reliability of the full black module, let us see the temperature characteristics. Actually, it is the same. For example, on the Pmax temperature coefficient, this is a measure of how much of the panel efficiency decreased by for each 1 degree increase. So when the panel temperature over 25 degrees, as you can see, both the panels performed well by the same number of the minus 0.36. So what we are offering now to the market, there are two models that we are offering to the market. From the left chart, as you can see, that is S2 series. The cells that we are using on the two models, it is from the 1508 millimeter cell. The left one, the output is up to the 330 watts, and the efficiency is up to the 19.49. And this model, it is in the 60 cells. The right part then is S2, I call S2 Plus series. The output can reach 365 watts, and the efficiency can reach 19.67%. And for this model, the cell that we are using, it is 66 cells. The reason that we are introducing these two models, that is because maybe some customers, they have a very limited space available, but with higher demanding on the system, and also different module dimension for various rooftop layout can give them more choices when we do the system design. So that is all my presentation, and next I think will be the Q&A. If you have any question, just ask us, or you can also send an email to me. Thanks, Mark.
Thank you, Carl, for this presentation. We do have time for Q&A, but just to let people know that when the webinar slides actually disappear after the session, the webinar platform is actually still live, and Seraphim staff will be able to answer any more questions you may have. So there's no rush to exit the platform when the slides disappear, if that's of help to you. Okay, Carl, so first question for you.
Yes.
Obviously, you're integrating and putting in some new materials for this product. And not surprisingly, people have asked, what tests have Seraphim undertaken on the all-black modules to prove the reliability?
Okay, thank you. Actually, Seraphim has a very strict regulation when we introduce the new material or the new product to the market. And all this test is depending on our advanced test lamp. In Seraphim test lamp, we have now been accredited by the CNAS and also obtained the TUV suit, the testing and manufacturer's premise, and also from the CSA for the WMTC, witnessed manufacturing testing for certification program, and also from the CTV for the authorized lamp qualification. So it means under the monitor from the CTC, TUV suit, or CSA engineers, our test results can be certified on site. This kind of authorization can really help us to shorten the certification time and speed up the pace of the new products into the market. In our test labs, we mainly do the three big groups of the test, like the performance testing, environmental testing, and safety testing. Like in performance testing, we can do like the maximum power verification, the TC, and LIP, and also in environment testing, we can do like the UV pre-treatment, the humidity freeze, PID or thermal, and the cycling and damp heat, hot spot, endurance test, and highly accelerated temperature and humidity stress test, we call it HAST. Like in the safety testing, we can do like diodo bypass test, mechanical loading test, high impact test, the wet liquid test, and also insulation test. So it means any new product that we bring to our customer, definitely it is under the very strict testing.
Okay, that's good. Thank you, Carl. We do get a lot of price-orientated questions, but typically we don't normally respond to that type of question. But perhaps, Carl, you could explain the general costs, related to the all-black modules, because obviously this is a non-standard type module. If that would help people, I think.
That is a good question, but a half question, a very challenging question. Sometimes we don't talk about the number of the price in our webinar or in our conversation. It is common that is full black module price a bit higher than the regular one. The reasons it is mainly because of the blank frame, black backsheet that we are using. The material cost is higher, and also you want to get the very higher output for the full black module. You have to go with the higher cell efficiency. But sometimes we say it doesn't matter if the cat or black or white, as long as it can catch the mice. But if we talk about on the rooftop systems, if we think from another aspect, the difference is that a more beautiful roof may have implications for your home resale values. This additional value could mean maybe much more than the entire cost of the solar panel system, especially in some major cities in global. So I think additional benefit that a beautiful aesthetic roof solar system definitely can improve your value of the whole house.
Okay, that's a good answer. I like that one. Now, another question here. We actually didn't cover this question, Carl, but in your presentation. But this question is asking whether Seraphim has any new plans for your existing shingled cell type modules. Now, those have been on the market for a fair few years. But perhaps you can just give, if you can, give us an update on the shingled technology.
Thank you for this audience question. I think definitely it is our customer who has used our shingling module that we call Eclipse series. The Seraphim is the world's first one company to put the shingling cell module into the bulk production. Shingling technology removes all the cell gap area and fulfilled by the cells to achieve the superior module power. The special no-ribbon design on the cell surface not only can maximize the effective area of the shining line, but also can give the all-blank appearance. As we all know, shingling cell technology is kind of innovation from the module processing part, not from the cell technology. So it can combine with the latest cell technology and to double the upgrading effect. As we all know, these 2 years, because of the big size cell applied and changed very quickly from very beginning like the 158 to 166. And this year we talk a lot about 182 and even to 10. So we have to say it did challenge our development on the shingling module. The new model from Seraphim from our shingling series, it is under developing and design. It means we have to choose the right cell and to go with the new design. So I think by the end of this year, there will be a total new shingling module from Seraphim. I think definitely it will surprise everyone. So let us see what Seraphim can bring to everyone.
Okay, fair enough. If we can just keep on that wafer size transition point for a minute, there's another question. It's a good question here. So obviously we're seeing half cut and a variety of different cell interconnect technologies becoming standard. But do these, the question here says do these technologies combined actually reduce the need for PV optimizers or microinverters? Because obviously being used in residential rooftops, you've got a higher expectation or potential for shading issues. And of course, half cut, as you mentioned in your presentation, you're actually limiting the power degradation because of that shading. So what's your views on the fact that this question is really saying, do you still need optimizers or can we do without them?
I think definitely for sure that we still need the microinverter or the optimizer, because no matter of the half-cut cell or the cell interconnect technology, it can hardly to replace the function of the microinverter or the optimizer, because to reducing the shade impact is just one benefit that this tool can bring to the customers. Like there's a very big brand and on the optimizer, they have at least 3 or 4 different function choices, like the optimization and fire safety and monitoring. Like the point that we discussed in my presentation, the rapid shutdown is one example that cannot be achieved currently through the module itself side. So on the other hand, as we all know, the larger the cell is, maybe the higher current it is. So it means, if we think about from this aspect, so it means the inverter, microinverter, or the optimizer is needed more than before. So in my opinion, the microinverter or the optimizer can definitely not be replaced by the module itself.
Okay, that's good. I think raising that issue, I'm assuming it's because the performance, we're talking about a significant increase in performance for traditional residential rooftops. So the fact that either microinverter optimizer really still does deliver greater performance, and you would suggest that people still, if where they're required, that's what you would use. Okay. So hopefully that's helped someone there understand that response. Another one here, I guess, I mean, it's something that you refer to with the two sizes, but you've highlighted obviously the 60 cell and the 66 cell formats because, and again, they're large. The 66 cell format is larger wafer size, but is Seraphim planning to offer, smaller sizes for smaller residential rooftops? As we know, there's a lot of, to maximize that rooftop, often, a smaller size is required. You can't just use what's technically known as, standard size modules. What's your view there?
Frankly speaking, till now, we don't have this plan to expand our full black module series from this range because it is limited maybe by our production line itself. But we have another range from our shingled module we call the mini eclipse, and the output it is from the 70 watt and some 70 watt to 230 watts. So it means you can choose from this range for the smaller size, the module that can suit for your rooftop areas. And if you need information, you can go to our website. You can download our datasheet there and to find the right product for your project.
Okay, all right, that's okay. There's, from your presentation, so this is someone just responding to noticing your presentation about having a module assembly plant in South Africa. And the question's really asking, are the modules made there able to be shipped, to non-African countries? What can you tell us about that particular plant, please?
Yes, we did establish the module factory in South Africa, and we are also preparing a cell factory in South Africa too. And the capacity there for the module, it is about 300 watt. And so the South African market is also with great potential. I remember last year, the capacity from the South Africa is about 1 gigawatt. And in the following several years, I think this market definitely with a very promising future. And furthermore, they also have something like the DCR policy for some projects. And this also reasons that we set up the factory. So we set up the factory in South Africa, not only for the local market and also for the whole Africa areas. And meanwhile, after our cell factory is ready, I think there's another key market for it that will be the USA. But for the rest areas like Europe or Latin America, if there's any demanding for our modules from South Africa, we definitely can discuss. So it is available for negotiation.
Okay, negotiation. Okay, thanks. Again, picking up on a comment here, question, looking at the temperature coefficient factors here, and you highlight this to a degree, but it seems that the all black modules, the actual, for argument's sake, the Pmax temperature coefficient is pretty much in line with just standard modules. So the question's really asking, what is behind that? Why is that achievable when it's been not? People have historically thought that this was one of the limitation factors for all black modules?
I think why someone has such kind of like the information or the image about that full black module, the TC, the PMAX temperature efficiency should be lower. It is because of the black backsheet and the frame used, and because of the heat radiation is not so good compared with the silver backsheet or the frame. But actually, the PMAX temperature coefficient has no direct relationship with the heat. It is mainly decided by the cell itself. And with the very quickest improvement on the cell specification, cell technology, it can also help to improve the module's temperature efficiency, performance. So when we introduce this full black module, we do the test, and the result that we got, the number for this PMAX temperature coefficient on the silver module and also the full black module, it is the same. So after test, we are 100% sure that we can give our customers the same quality module as they buy on the traditional ones.
Thank you for that. I don't think we're going to get any extra looking at the time. I think we've pretty much going to close down. But once again, people can stay on to the platform. I see there's questions there coming through, so people are answering them. But thank you very much, Carl. Thank you, everyone, for attending this PVTech Tech Talk Product Series webinar, and hope to see you soon at the next one. And that's it from us today. Thank you very much. Goodbye.
Thank you for everyone. Goodbye.